Okay, so ADI, or alternating direction implicit method, is a technique that splits the domain and allows us to use both the explicit and implicit methods to solve our finite difference scheme. Okay, so we have to start off with that day phi by day t is equal to some diffusion coefficient, day squared phi, day x squared plus day squared phi, day y squared. Okay, so our first half step, remember from the previous video, first half step that goes from Tn to Tn plus a half, is calculated as follows. So phi ij to n plus a half minus phi ij at n divided by half our time step is equal to the diffusion coefficient multiplied by phi I plus 1j at n minus 2 phi ij at n plus phi ij I minus 1 j at n divided by delta x squared plus phi I j plus 1 n plus a half minus 2 phi ij n plus a half plus phi I j minus 1 n plus a half divided by delta y squared. And then that, for an equally spaced grid, so delta x equals delta y, can be summarized as minus lambda phi I j minus 1 n plus a half plus 2 1 plus lambda phi I j n plus a half minus lambda phi I j plus 1 n plus a half, which is equal to lambda phi I minus 1 j n plus 2 times 1 minus lambda phi I j at the nth time step plus lambda phi I plus 1 j n. Okay, so just remember that now lambda is equal to k delta t over h squared, because delta y equals delta x. Alright, so we then move on to our second half step, that is going from t n plus a half to Tn plus 1. And we have the following formulation, that is phi ij n plus 1 minus phi ij n plus a half divided by half our time step is equal to the diffusion coefficient multiplied by phi I plus 1 j n plus 1 minus 2 phi I j n plus 1 plus phi I minus 1 j n plus 1. Now it's the I terms that are changing, so that's delta x squared plus phi I j plus 1 n plus a half minus 2 phi I j n plus a half plus phi of I j minus 1 n plus a half. And now it's the j terms that are changing, so we divide by delta y squared. Okay, and this can be summarized as minus lambda phi I minus 1 j n plus 1 plus 2 1 plus lambda phi I j n plus 1 minus lambda phi I plus 1 j n plus 1 equals lambda phi I j minus 1 n plus a half plus 2 times 1 minus lambda phi ij n plus a half plus lambda phi I j plus 1 n plus a half. So quite tedious, but important nevertheless. And in order for us to get a tri-diagonal matrix to solve these systems of equations, we have to apply this ADI method in one direction at a time. So it has to go across some type of sweeping technique. So what I mean by that is if we have the x and the y plane, that looks something like this, x, y, and we have nodes here. Let's draw them nice and big. I first have to choose one direction and solve my my set of equations in that direction. So let's say, well, let's just write the node numbers. So this is 1, 1. This would be 1, 2, 1, 3. This is 2, 1, 2, 2, 2, 3, 3, 1. So that's obviously the third x, first y. 3, 2, and 3, 3. Okay, so first I would solve to carry out my solution in the y direction. So that is, let's just draw that arrow. So follow the red line back to the start here, carry out our solution, back to the start here, carry out our solution, and then we would carry out the solution in the x direction. So we would start here, and go back to the start, propagate our x solution, and sweep across in this direction. Now that's really important for us in order to solve these sets of simultaneous equations effectively.